Residual pump head graphs. So what I've drawn out here very roughly is a pump head graph. So I'm showing that at zero flow, or a dead head, we're going to generate 7.5 meters of head with this pump, similar to the one on the Wiesmann boiler. And I've just picked some arbitrary flows. I don't know what the actual pump curve is, but this is just for demonstration purposes. And I've picked a flow rate here for 30 kilowatts at DT20, and just struck a line up here on my made up curve to illustrate a point here indicating that we're generating at this flow rate a head of 3.5 meters. Then I've plotted some other flow rates along the same curve this way, to show that as the flow reduces, the actual head generated, or the pressure generated, is higher. And then I've plotted against it the heat exchanger curve. Now, because we know this point 3.5 here, or this flow rate, is the expected result, we know that our heat exchanger curve will pass through that point, and that it also starts at a point of where there's no resistance and no flow. So we know flow is no resistance. As the flow increases, so does the resistance. So we end up with the resistance to flow curve, if you like. And then if we plot these various performance points along this line, we get this other residual pump head data. And then if we take these data points, these data values, and plot them onto a second graph using those points, we will get the curve that represents the residual head of the pump. And as you can see, the curve does change slightly in its shape. Actually, it doesn't look so obvious there, but excuse me. But either way, residual pump head would show how much pump head we've got left at any one point. So at a flow rate of 1,250 litres, here we would have the residual. So if we started with 7.5 on this one, less 3.5, that would give us a residual pump head of 4 meters. So this would be 4 meters in there. The residual pump head for this one is going to be about 5.5. And for the further one, I'll put about 5.5, 6 meters head. So that at this low flow rate, we've got the spare head available to run a system of 6 meters. At this flow rate, we've got the spare head available, residual pump head, to run a system against 5.5 meters of head. And at this flow rate, we'd have enough pump head to run against a system with a resistance of 4 meters head. So I know it's not totally clear, but I've just knocked this up in a few minutes. I'll try and do something a bit clearer later, but this is my understanding. So the residual pump head is the pump head that's left over when we plot the increase in resistance through the heat exchanger due to flow against the loss of head in the pump, or the gaining of head, if you like, as the flow reduces, and the loss of head as the flow increases down that pump curve line.